Hey, feeling good, like I should. When in dark, I walk around the neighborhood, feeling blessed.
Right. In this lesson, we are actually going to reacquaint ourselves with the slope-intercept form of an equation, which is y equals mx plus b. That's the title of this lesson for 7.2.1. And we are going to it's almost like it's a game. We're going to put ourselves in a situation where we're pretending like we work for a company there where we create lines. And customers place their orders, and we need to make sure that everything is correct. So really, in essence, what this is all about is kind of going back and reviewing what we learned in earlier chapters about the different representations of linear equations and linear functions. Okay, so let's get started on this. This could end up being a relatively quick lesson here. Slope-intercept form, if you recall, it's when you have a two-variable rule that is solved for y. So being solved for y means we got y all by itself on one side. This is called slope-intercept form because here you got your y and your x, those are your two variables, and you got your parameters, which actually that might be in a later lesson. Your parameters are the slope or the growth rate and your starting amount or your y-intercept. Okay, so slope, y-intercept, when you've got the equation in this form, you can tell both of those pieces just by looking at the rule. And one last part, this is referred to as a linear equation because when you graph it, it forms a straight line, right? There are other kinds of equations that are nonlinear because when you graph those, they form curved lines. But this is the basic slope-intercept form for all linear equations. So, previously, you developed ways to find the growth of a line using a rule, table, and graph. You also learned how to find the y-intercept, or how the y-intercept is present in each one of these representations. In this lesson, you will enhance your study of lines and will develop ways to find the equation of a line using different pieces of information about the line, such as 2 points that are on it, or I suppose if you know the slope and 1 point and whatnot. So today's lesson will help you preview connections you made in previous chapters by challenging you to find equations for lines from multiple representations. All right, so here's the premise. Congratulations, you have recently been hired to work at the city's premier line factory. People from all over the country order their lines from your factory because of their superior quality and excellent price. Lately, however, the line factory is having a serious problem. Too many customers have placed orders and then have received lines different from what they had wanted. The factory has hired your team to correct this problem. Okay, so what we're going to do is we're going to review some recent orders and we're going to decide whether or not a mistake was made by the customer or whether the mistake would have been possibly made by the factory itself. Okay, so we're going to have a bunch of different customers A, B, C, D, E, and F, and then we are finished. That's how quick this should go. Okay, so let's just get to it. Let's start with customer A. I'll choose that as my, okay, that'll work just fine. All right, so customer A wants a line with a y-intercept of 0, -3, and it grows by 4, okay? So pay no attention to this right here. This is for problem B, not for this problem here. So what do we notice? The customer ordered y equals -3x plus 4. Now, if you recall, y equals mx plus b is the slope-intercept form where m represents the slope of the line, that's what it grows by, and b represents the y-intercept, or the starting point. So when it says here that she wanted a y-intercept of 0, -3, looking at the equation, I can already see where the problem is. She wants it to grow by 4. That would be the slope. And you can kind of see what happened, right? Can you kindly fix her order and tell her what the equation was supposed to be? If she wants a y-intercept of -3 and a growth rate of 4, what should the rule state? If you said it's supposed to be y equals 4x minus 3, then you are absolutely right. It was a simple mistake, but they got the slope and the y-intercept reversed or mixed up in the rule. Okay, so you see how this is going to go? Just like that. We're just going to look at the problem, see if we can see if they've got it right or wrong, and then make the necessary recommendations. In this case, we recommend that we change the order. If this is truly the y-intercept and truly the growth rate that you want, we're going to change the order so that it's y equals 4x minus 3 instead of y equals negative 3x plus 4. All right, now let's look at customer B, which has to do with this graph right here. It says, customer B wants the line graphed at the right. He ordered the line y equals 3x plus 2. All right, take a look at that line. Would you please identify the growth rate or the slope of the line and the y-intercept of this line and make the determination of whether or not you believe this customer placed the correct order with y equals 3x plus 2. I'm going to go ahead and pause while you think that through and figure that out. All right, I figured out the problem. Have you figured out the problem? The rule here suggests that the y-intercept should be at positive 2, and it is. There's nothing wrong with this y-intercept being at positive 2. But I have a problem with the line itself. This does not have a positive growth rate. In order for it to have a positive growth rate, it would have to go 1 unit to the right and 3 units up, right? Both of them going in the positive direction. That's what this says. But they want this line, and for this line, it actually goes down 3, 1 to the right, down 3, 1 to the right, which suggests that the slope should be negative 3 over 1 or negative 3. So if he wants this line, he's got to change that rule from y equals 3x plus 2 to y equals negative 3x plus 2. So the y-intercept was correct, but the slope ratio was wrong. Now let's look at customer C. Customer C wants a line that passes through points 2, negative 4, and 5, 2. She ordered this. Okay, so why don't you go ahead, plot these 2 points on a coordinate grid. You're going to have to take a little time with your graph paper and create a coordinate grid. Plot those points, connect those dots, and see if your graph doesn't cross over where x is equal to negative 8. I'm going to go ahead and mark this right now. We want this to be at negative 8 right there. And we need there to be a growth rate of up to 1 to the right, up to 1 to the right, up to 1 to the right. Okay. Go ahead and finish this graph, plotting those points, and see if this line doesn't pass through there. If it doesn't, we're going to have to figure out what is the rule for the line that passes through these 2 points. Okay. So once again, customer C wants a line that passes through these 2 points. Is this the right equation to go with what customer C wants? Okay, go ahead and figure that out. All right, so a couple things that I've noticed here. First off, the y-intercept of our line is at 0, negative 8, and the growth rate is positive 2, right? So there's your y-intercept. Here's your growth rate that coincides with what we have, our rise over the run. It goes up to 1 to the right. And notice that this does actually pass through 2, negative 4, and it passes through 5, 2. Therefore, we can conclude that customer C has done a splendid job. This order is correct and can go ahead and be shipped. See how much fun this is? I thought you'd like it. It's kind of interesting. All right, now let's figure out for D. Customer D wants the line that is represented by the table below. You have to figure out what that rule should be. So this one's a little bit different from some of the others. Maybe I'll work this one out for you. One thing that I'm noticing is this, that the values for x are increasing by 1 every single time. And remember, the slope of the line is always equal to the change in y over the change in x. So if every single one of these increases by 1, we need to have every one of these increase by the same amount as well. So that goes up by 3, right? This goes up by 3. There's a problem right there. Our growth rate is supposed to be plus 3 every single time, but this is plus 2. And then this one's plus 3, and this one's plus 3, and this one's plus 3. Yeah, no, this doesn't work. There's not a constant growth rate. I would like to say that the slope ratio is 3 and the y-intercept is at 4. So we would use the rule y equals 3x plus 4, but that's not going to work for all of these. Like if you look right here, negative 3 or 3 times negative 1 is negative 3, and negative 3 plus 4 is 1. It's not 2. So this rule is not going to work for every single ordered pair on that table. So there's a problem. Customer D wants a line as represented by this table, but this is not going to form a straight line. Let me see if I can show you on here what the problem is. Let's take negative 3, negative 4 is located here. Negative 2, negative 1 is located here. Negative 1, 2 is located here, and then 0, 4 is located there, and that becomes the problem. It slightly shifts, and then it goes straight again. So I'm going to go ahead and complete this. This is 1, 7, and 2, 10, and that should be enough for us to see that when we try, let me do it in blue. Let me make it nice and thin here so you can see this. It's just off. While it passes, is it not giving me an accurate? I want to show that it's not working. It's not supposed to be working. And of course, it's, yeah, see right there, it's supposed to go a little bit to the left of each one of those while it passes through there. So this does not work. So our recommendation is going to be send this back to the customer. This table does not represent a linear equation or a linear function. Change it up. Do you want this to be 0, 5, or do you want this to be negative 1, 1? Which one should it be? There's a mistake here. Fix that, and then we can make the line for you. All right, now let's take a look at E. Customer E ordered a line that is 2x minus y is equal to 4 and wants the line to grow by 2 and pass through the point 5, 6. All right, so it's going to have a slope of 2, but I don't necessarily know what the y-intercept is yet because this equation is not in slope-intercept form. So maybe that's the first thing we should do. Let's clean up our workspace over here, and let's rewrite this guy in slope-intercept form. So 2x minus y is equal to 4. To get this in a slope-intercept form, I think what I'm going to do is this. I'm going to add, no, let's not do that. Let's go ahead and just take away 2 x's from each side. So this becomes negative y is equal to negative 2x plus 4. And now I'll divide everything by negative 1 to change everything to their opposites. Instead of a negative y, this becomes a positive y. Instead of a negative 2x, that becomes a positive 2x. And instead of plus 4, it becomes minus 4. So we have what they want. They wanted a growth rate where it grows by 2. That's good. We've got that. But now we have to determine whether or not this is going to pass through 5, 6. So we could do one of two things. We could either plug in the 5 here and the 6 there and see if that works out. 2 times 5 minus 4 has to equal 6. Is 10 minus 4 equal to 6? Yes, it is. So it appears as if everything is fine, that this works. But I want to double check it. Let's take our rule, which is y equals, so our negative 4 is going to be our y-intercept, and our growth rate is going to be 2. So we're going to go up 2, 1 to the right, 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 up 2, 1 to the right. Does this line pass through 5, 6? And I believe it does, because this point right there is where x is equal to 5 and y is equal to 6. So, good job, customer E. You ordered the correct line because this one has a growth rate of 2 and it passes through 5, 6. All right, now for the last one, and we are done for today. Customer F wants a line that starts at 0, 1 and grows first by 3 and then grows by 5. Can you provide them with that rule? Go ahead and think about that and declare your answer. All right. So you might have, from the very beginning, noticed that there's a problem with the premise of this problem. He wants a line that starts at 1, right? That starts right there, and or that's the y-intercept anyway. I guess I didn't have it start at 1, but I guess I can fix it a little bit. Let's do that and do this and do that, and hooray, we got that fixed. All right, so it starts here, but then it grows by 3, then it grows by 5, which means it doesn't have a constant growth rate, which means this rule for linear equations doesn't apply because it's not a constant growth rate throughout. So we always want our lines to be perfectly straight all the way, but this one starts off a little bit flatter, and then it steepens. So it's almost like there's a little curve happening there. So kind of similar to the problem that we had for customer D is this does not represent a linear function. This is not linear at all. It needs to have a constant growth rate. So it needs to be sent back to the customer. They need to either decide, do you want it to grow by 3 or grow by 5? Choose one, and then we can make an equation for you, okay? Or then we can create a line from the equation that is generated. So there we go. We are done with this lesson. A little bit of review on slope and y-intercept and how to plot points on a graph and connect the dots to form a straight line. We're going to use this to help us with our scatter plots now, because we are going to be creating lines of best fit, and we need to generate a rule for our line of best fit, and that rule will then define whatever the scatter plot is showing us, and we'll be able to use that rule to make predictions to solve problems. All right, let's move on to the next activity. Bye-bye.
Hey, feeling